All right, kids. Hey, guys, we're going to start taking some of the ideas we've been working with in terms of expanding polynomials, and we're going to kind of work backwards a little bit today. And what we're going to start looking at is not just the expression form of it, but we're going to start looking at stuff in an equation form. And guys, anytime we start dealing with equations, what sign is always going to show up with equations? It's going to be an equal sign every single time, okay? So guys, anytime you have an equal sign right here, this means we're going to start solving for a variable. Okay, you're always going to be solving for a variable. So today, since we are dealing with equations, you're going to get to the point like x equals 7, or x equals my favorite number 6, or whatever it might be. Okay? Anybody else have a favorite number 6? You guys know what today is in October?
Your birthday.
I was born on the 6th. My favorite race car driver drives number 6. Today is my daughter's birthday, born on the 6th. Yeah?
Today is your birthday?
No, my youngest daughter's birthday today. And bless her heart, she wants to go to Tokyo Bay tonight. So I'm like, dang, I've got to go there. So bummed out. All right.
Bummed out for that.
Hey, we've only got one test, by the way, to get finished up. And then I'll have donuts for you, okay? Make sense to everybody? All right. Guys, when we solve polynomial equations in factored form right here, the question you want to ask yourself, how can you solve a polynomial equation, okay? So some of the goals that we need to accomplish today. We're going to use the zero product. There's a big definition for zero product, but guys, you really know it already. You've known it since elementary. Anything times 0 is going to equal what? So if I have one number times another number and the product is 0, one of those two numbers had to be what? One of those two numbers had to be 0, right? Okay. We're going to look at factoring polynomials using the, I heard somebody talking about this yesterday. GCF, which stands for what?
Given, center,
Greatest common factor. Okay, that's what we're after. Greatest common factor, all right? Next one, use the zero product property to solve real life problems here. We'll show what that looks like here in a second, okay? All right, here we go. Guys, we're going to get a lot of vocab today, so make sure we'll take good notes here. But guys, first one is factored formula. I'm not formula, but factored form. Polynomial is written as a what?
Try.
Okay, an example might be something like this. You might have like x plus 2 times 2x minus 6, like this. Okay, factored form usually has parentheses there. Okay, it usually has parentheses there.
Get the notes there also.
Okay. So factored form would look something like this. One polynomial times another polynomial. Two polynomials times themselves. Okay? Zero product. We kind of talked about this right here. It says if the product of two numbers is what? Then at least one of the numbers is what? Okay. This is kind of like saying the following. If A times B equals 0, that means A must equal 0. Or what else could be true, kids? B could equal 0. If A times B would equal 0, I don't know what A is, and I don't know what B is, but I know that A times B makes what value? 0. One of those values, or maybe both of them are 0. Okay? Guys, in this section, the next thing we're going to talk about are roots. We're not talking about growing plants. We're talking about a what? Solution of an equation. So if I had, I don't know, if I had x plus 6 equals 0, and I said, hey, what's the solution to that? You would tell me what? Negative 6. So if it's negative 6, I could also say, well, the root of that is negative 6. So anytime we talk about solutions, another term that we use for solutions is what? What word? Okay, so x would equal negative 6 here as an example. X equal negative 6 is a root to that equation. Okay? All right, repeated roots. Nothing tough here. It's two or more roots of an equation that are repeated. So sometimes when you solve the stuff we're going to look at today, In one of these right here, you might get x equals 6, and in another one you might get x equals 6. If 6 shows up more than once in your solutions, we call it what type of a root? A repeated root. All right? So it just happens, it's just a solution that shows up more than once. Okay, it's a solution that's going to show up more than once. Okay. The rest we should kind of know. Polynomial, we know what polynomials are. We've been working with polynomials a whole chapter. So an example of a polynomial would be, and I'll ask some review questions, maybe 3x to the 4th plus 2x squared plus 6. Kids, what's the degree of that polynomial? 4. What's the leading coefficient? 3. Okay. By family, what type of polynomial is that? Why is it a trinomial? It has 3 parts or 3 terms, right? Okay. Guys, is this polynomial that I just wrote in standard form right here? Yep, because the exponents go down from largest to what? Smallest, okay? So I don't need to write that, I don't think. All right, greatest common factor. It's the largest factor of 2 numbers or terms. This is going to show up today. I'm going to throw 2 numbers up here. 24 and 20. What's the largest factor that would divide into both 24 and 20? Let me ask this question. Does 1 go into both? Is that the biggest? Will 2 go into both of those? Yeah. 4 go into both of those? What's the largest number that's going to divide evenly into 24 and 20? 4. So the greatest common factor of that would be 4. So in an example like this, greatest common factor is 4. Because 4 is the largest number that will divide evenly into both 24 and into 20. And then the last thing is a monomial. It's a number, a variable, and I didn't fill the rest out, or a number and a variable put together, something like 6x to the 7th. Okay? It's just mono meaning what? It's just one term. Okay? So a lot of vocabulary today. Again, I don't expect you to memorize it, but if you don't understand what something means, look at the examples we provided with the written definition. I really think that those examples help out a lot. Okay? You guys ready to rock and roll some pretty easy stuff today? You guys want to make shredded cheese out of this? That sounds pretty good. Let's roll, kids. You guys are awesome. Okay, core concept today. We need to differentiate between what's known as factored form and what is standard form. Guys, everything that we've done so far in sections 2.1 to 2.3 is to say, take something like this and write it so that it looks like something in standard form. So what method did we apply to expand this right here? What's the name of that method? Start with an F. Yeah, we FOIL it out. If I would FOIL this out, we FOIL factored form into standard form. We get rid of parentheses, in other words. So guys, help me with the first part. What's x times x going to give you? Okay. If I looked at the inside and outside part, the outside part right here would be what, kids? Inside part would be, what's 2x and 6x going to combine to for the outside and inside part? And then help me do the last part. We did the first x and x. I do the inside, outside underneath there. What's the last part? It's going to be the 6 and the 2, in other words. 12. Okay. Guys, when I FOIL this out, go in this direction right here, we go from factored form to what? Standard form, okay? Are these two expressions equivalent? The answer would be what? Yes, in fact, if I went into decimals and typed this part in, and I went into decimals and typed this part in, what would you expect about the two graphs? They would be exactly the same thing. They look totally different, but they would be the exact same thing. Because didn't this standard form come from FOILing this factored form right here? Okay, you understand the difference. Factored form is typically written with what, kids? Parentheses. Okay. Let's get to the heart of the matter. Let's start accomplishing some goals today. All right? First thing we need to do is look at this right here and solve polynomial equations. Okay? So our job is simply this. Guys, we talk about zero product again. Don't forget this. This simply says if two numbers multiply to 0, then either the first one or the second one must be what? So A can equal 0 or what? Okay, well, in this example right down here, they say solve these equations. And down here, kids, they say 3x times what here? X minus 6 is equal to what here? 0. Okay, now how many terms are really up here? Or how many parts are there really up here? Or really, how many sets of parentheses, if I would put parentheses around 3x, how many sets are really up here? Well, one set is the 3x, the other set is what? Okay. If 3x times x minus 6 equals 0, that means that either the 3x is equal to 0, or what else? X minus 6 has to equal 0. Okay? We're trying to find values of x. So this is going to make this equal to what value? Okay, help me out here, guys. If I set 3x equal to 0 right here, how would you solve for x right here? Divide by what? So x would equal what value? 0. Okay. All right, so let's just check that. What is 3 times 0, kids? Bank that number in your head, 0. What's 0 minus 6 right here when I put that in? What's 0 times negative 6? So when x is 0, do we get a product of 0? So one solution must be what? Well, 0. Okay? So I set this first part equal to 0 and solve. We got x equals 0. Or I could set this second part, x minus 6 equal to 0 and solve it. So what would you do to both sides here to get x alone, kids? Add a 6. All right, talk to me, kids. What's this going to be? So my two possible solutions here, x equals 0 or what? Okay, now I'm going to make a connection here and show you something, but watch this right here. If I throw 6 in, what's 3 times 6 into the original equation, kids? 18. And now what's 6 minus 6 here? 0, right? Well, what's 18 times 0 going to make? 18. Now I want to make a connection here, and I want to show you this really, because this is really pretty cool. We think the two answers are possibly 0 or what here, kids? Okay, let me go into decimals real quickly and just kind of show you this. This is kind of neat. I want to show you this real quickly. Guys, what's the x value of this point on the x-axis where the graph crosses? What's the x-axis here? Ooh, interesting, huh? This is like saying when x is 0 right here, your equation is 0. Or when x is what value here? Your equation is still what? 0. Okay? Is there a way to check to know we're right? Is there a way to check to know we're right? Absolutely. Okay, now again, I don't think you'll need to go that route because I think that this is pretty straightforward and pretty basic, so I think we'll do pretty well with it. So let's do this. You guys, I think some of you might be ahead of me already. How would I set this one up right here? If I had the quantity x minus 5 times x plus 4 equals 0, how would I solve that? What would I set equal to 0 first, kids? X minus 5 equal to 0. Or what else could happen here, kids? If I solve this first equation, what's one possible solution for x? 5. 5 would make this true. Okay, because kids, what is 5 minus 5 up here? 0, and then 5 plus 4 is 9. 0 times 9 would be 0. Or what's the other one going to be if I choose to solve this over here? Okay, so what are my possible roots here? Well, you would tell me it's 5 and what else? Negative 4, right? Are those repeated roots or not? They're different, aren't they? So if they're different like that, they're not repeated. Nothing repeated. Okay? All right, let's try some more. This is kind of the concept today. This is what we're doing. This is really all we're doing today. That seems pretty easy, doesn't it? Right? Questions so far? All right. Let's try another. Ooh. Okay, no problem. No problem. Guys, it says 4x plus 5 times 4x minus 5 is equal to what?
0.
Well, that's the same as saying, well, 4x plus 5 could equal 0. Or what else could happen?
4x squared.
Yep. All right, my friends, this is like that two-step where I said, let's not assume anything. Let's make sure we know how to solve this. How would you solve this first equation, kids? What would be your first step right here? Yep. I subtract TV of 5. All right, don't make this into a rap, Parsons. Settle down. 0 minus 5 would be what on the right, kids? Okay, and then divide by what? Now, kids, some of them might say the answer to this first part is x equals negative 5 over 4. Some of you might choose to divide that out. Anybody know what negative 5 divided by 4 would be as a decimal? Negative 1.25. So I don't really care if you leave it in fraction form or decimal form. I prefer decimal form. I would probably write this as negative 1.25, but I'm okay with that. Okay. Or how about the second part, kids? What would be your next step here? So I've got 4x equal 5, which means x would equal what? 5 over what?
4.
So x can equal negative 5 fourths, or x could equal positive 5 fourths there. Okay. Now again, if you want to put those 5 fourths as 1.25, I'm all for it. Right? I'm all for it. Okay. The second one right here, kids. C plus 6 squared is equal to what?
0.
Well, isn't that really the same as saying C plus 6 times itself, kids? Okay, let's just see if we can do this in our head. Let's just set the C plus 6 equal to 0. What has to go in for C to make this first quantity 0? C would equal negative 6 in the first one. What would go in here to make that? 0. Ooh. So each time we got C equals what, kids? What kind of root do we call that?
Repeated.
That's a repeated root. Okay. How many roots are you going to get in the last answer? You guys go and find them, okay? You're going to set a plus 5 equal to 0. You're going to set a minus 2 equal to 0. You're going to set a minus 7 equals 0. I'm guessing you may not even have to write anything but the answers for that. Anybody ready to throw down some answers for this? What's 1, Corbin?
Negative 5.
Negative 5. Because, guys, if I put negative 5 right in here, what is negative 5 plus 5? 0. So I don't care what the rest is. 0 times the rest of this mess is going to get you what? Okay, what's another one? Yep, because 2 minus 2 would make 0. Or what's the last one, kids? You got it. Okay. You know, show of hands. How many are like, yeah, I think I'm okay with this. Just set each part equal to 0 and solve right now. Okay. Pretty straightforward, isn't it? All right, my friends. Any questions to this point right now? Okay, so A could be negative 5 here. A could be 2. And A could be 7. Okay, you guys are rock stars. You're doing great here. Okay. Now, kids, if I thought maybe there's a part where things can get a little tricky, I thought starting example 3 might be kind of tricky. So I'm going to put a little star or a pentagon by it, I guess. This is supposed to be important. I don't want to... Lexi, I can't see those up there. Will you help me? Which one's the star?
Right there.
Right here?
Yep.
All right. This one's kind of an important one. Guys, here we go. This is called factoring out the greatest common monomial from stuff. And factoring stuff is going to help us moving forward. In fact, once we get through with this section right here, the rest of the chapter is going to involve what's known as factoring. And things in chapter 2 are going to get a little more difficult as we progress beyond this section. But we might as well start learning a little bit about it now, okay? You guys remember on the example here, I said, hey, what's the greatest common factor of 24 and 20? You told me what? 4, because 4 is the largest number that will divide evenly into 24 and 20. Now kids, the same concept is going to apply when we start trying to factor out monomials from this, in this case, binomial, okay? If you look at this right here, it says factor out the greatest common monomial factor from what and what, kids? 12x to the third and what? 3x to the second, okay? Now, a couple different ways I can do this, but I want you to kind of think about this way. First of all, just look at the 12 and the 3 right here, all right? Can you think of a number that would divide evenly into 12 and 3 other than 1? Furthermore, the largest value that would go into both? 3. How many times will 3 go into this? Well, not sure, okay? Now, take a look here, kids. How many x's are really behind this 12? 3, right? How many x's are behind this 3? Okay, so think of it this way. This 12 is like 12x to the third, 12 times x times x times x, right? And 3x squared is like plus 3 times x. All right, we've got to be careful on this, kids. If I take 3 from 12, what factor is left? Now, maybe before I even go there, maybe I should ask this question. These first two terms, 12x cubed and 3x squared, how many x's can I take so that I take the same amount from each term? 2. So I'm going to factor out a 3 and an x to the second. Okay, so watch what happens here, kids. This becomes 3x squared times the following. This 12 times x times x. When I take 3x squared out, what's the 12 over 3 make right here?
4.
Okay, and then this x, we took 2 out of 3 x's away when I factored out. We took 2 out of the 3 x's away, so how many x's would remain here? Okay, now over here I took out a 3 and an x and an x. Ooh, we took out what, kids? We took the whole thing out. We factored out the whole thing. Now guys, think about this. What would 3 times x over 3 times x times x divide out to be? One thing divided by the same exact thing would be what? 1. Yeah, if you take everything out, you assume there's a 1 left. Now I've done a bad job of writing this. But kids, your factored form here then would look like this. Your factored form would look like this. This is the same as 3x squared times 4x plus what? Okay, now I don't know if I'm right, but we could check to see if I am. What's 3x squared times 4x, kids? What's the 3 times 4 going to get you? 12. And then x squared next to the first would be x to the third. Did that give me back what I had here? Okay. What's 3x squared times the 1? 3x squared, same thing. Now again, kids, if you weren't sure, here's another way you could do this. You could walk right in here and say, okay, my function was originally, all right, help me out, kids. What was that function originally? 12x to the what? So I'm going to type in right here 12x to the third plus 3x squared. Is that right, guys? There's the graph of that right there. Now, if I factored this correctly, what should happen if I put my factored form in? Should go right over the top of this. So blue is going to switch to what color here when I do this? Well, what did we call this first? 3x to the what? Okay, so shouldn't the green one completely cover the blue one?
Yes.
What do we have in parentheses, kids?
4x
Oh my goodness. Did it work? Same graphs? So factored form must be
Correct, right? That's fun. All right, I'm done. All right. So you're trying to look at the biggest part you can pull out of each term here to factor this, okay? So let's try and apply this right here. There's a reason they want you to do this, because kids, we are good at solving equations in factored form. Kids, if I had to solve this equation right down here, are there sets of parentheses in this problem at all right here? Are there any parentheses right here just to set parts equal? I can't do that. So what we have to do here first is we have to solve equations by doing what? Factoring. Now this is going to become something that's very important as we move through the rest of the chapter, and it's going to get more difficult than this, but today we're solving equations by factoring out what's really the greatest common factor. So talk to me, friends. Look at these two terms, 4x squared and 12x. Think of the 4 and 12 first. What can you pull out of 4 and 12? What factor would divide evenly into 4 and 12 other than 1? 4 will go into both, right? Then, I want to pull some x's from both sides if I can, but I can only pull as many as the least amount in a term. So over here I have 2 x's. I can take out 2 x's here, but am I able to take 2 x's out over here? How many x's are really here? Just 1. So how many x's can I pull from each term? Okay, so what are we really factoring out front, kids? Okay, so why do we factor? Here's why. We're going to factor this 4x out. Now help me with my north of Highway 3 math. If I take 4x squared and divide it by 4x here, because we factored out a 4x, what's the 4 divided by 4 going to get you? 4 divided by 4 would just get you what? 1, okay? Then you've got an x squared over an x. What's x to the second divided by x going to leave you with? Okay, so we have 1x left, okay? Then I'm going to bring a plus sign down. How about this? What's 12x divided by 4x? 3, right? First things first, have I factored correctly? Just double check. What's 4x times x make right here, kids? Wasn't that part of the original problem right here? What's the 4x times plus 3 going to make? Plus 12x, right? Isn't that part of the original problem right here? What's this equal to still? Oh my gosh, and when we get to that part right there, how many parts do we have equal to 0? So what am I going to do to solve this now, friends? Set 4x equal to what? Or what else could happen? That's right, x plus 3 could equal 0. Okay. What's the solution over here on the left, kids? What's 0 divided by 4 going to be? 0, so x can equal 0 as a solution. Or what else, kiddos? Negative 3. When I subtract 3 from both sides. So guys, the two values that would make this equation true, 0 and what? 0 and negative 3. Now I could tie in a graph right here, but where do you think they're going to cross the x-axis at? What x values do you think they're going to cross at if I would graph this in decimals? 0 and what? Negative 3. Okay? All right. Now, guys, the whole idea has been that we set everything equal to what first? 0. Is this equal to 0? Ooh. Okay. But could I rewrite it so that it does equal 0? How about this? Could I add 10a squared to both sides here, kids? Okay, this one here is a tricky one. You've got to set equal to 0 before you can do anything. Set equal to 0 before you can do anything. Now, guys, when I add 10a squared to the left, what's that equal over here? So this would become positive 10a squared plus 8a. Now we've got a factor, friends. 10 and 8, what's the largest value I can take out of 10 and 8? Take a 2. How many a's would I be able to take from each term so that I can take the same amount from each? Just one. I can take a 2a from both. Kids, if I take 2a from 10a, what's the 2 going to turn the 10 into when we divide? 5 what? Okay, just check yourself. Does 2a and 5a make the 10a squared? Okay, I'm going to take 2a out of 8a. What's left there? Okay, so what two parts after I factored am I going to set equal to 0 now? I want to set 2a equal to 0. What else should we set equal to 0? 5a plus 4 is going to equal 0. And then we're off to our one-step or two-step equations. So very simply on the right, kids, 0 divided by 2 would be what? Okay, what would I have to subtract by on the other one? Subtract a 4 and then divide by what? 5. Wouldn't that just be negative 4/5, kids? Now, I know I'm going pretty quickly through this, kids, but the whole idea is to find factored form, something with some parentheses in it. And really, for the most part, we've had two parts equal to what value? 0. You set the left part equal to 0, the right part equals 0. I think there was one example where we had 3 parts equal to 0, right? So you set all parts equal to 0 and solve for each part. Okay. By the way, in example 4, are there any repeated roots anywhere? No. Okay. Questions regarding that part? All right, last page here. Make sure everybody have that down. Anybody need more time with the writings there? All right, friends. Last example. This is kind of a neat one. It says you can model the arch of an entrance to a train tunnel by using the following equation. Y equals negative 5/16 x plus 8 times x minus 8, where x and y are measured in feet. It says the x-axis represents what, kids? Okay, so right here, let's just graph this in decimals quickly and see what this looks like. Let's just simply graph this in decimals. Now guys, if I didn't know anything about this word problem right here, I would say, well, we've been setting all of our equations equal to what value?
0.
What do you think we'd probably take that equation and set it equal to? 0. Okay, well, by decimals right here, when I graph this, okay. How about a volunteer to read that model for me? What did it say? Was it negative 5/16 out front there, kids?
Negative 5/16.
Okay.
Parentheses, x plus 8, parentheses, another parentheses, x minus 8.
X minus 8?
Yep.
Okay, guys, the roots, they said the x-axis is kind of like the ground here, didn't they? Now, if you take a look right here, if the x-axis is the ground right here, we want to figure out the width of this tunnel. So here's my tunnel, kids. We're looking at just this part from here to here. The tunnel is right here. So that's really what you would see. What's the question say right here then? I'm going to say the width of the tunnel at the ground. Well, guys, how far left of the origin is this intercept right here, or this root? How many units left is that? 8. How many units of the origin are we to the right? So if I wanted to go from point to point, if this was the left edge of the tunnel and this was the right edge of the tunnel where it meets ground level, how wide is that tunnel entrance at the ground? It would be 16 feet here, wouldn't it? Okay. This reminds me of like one of those walk-through aquariums right here where the sharks are swimming up top here. Have you guys ever done that before? Anybody ever walked through one of those? You did? Where'd you do that at, Allie? Yeah?
Atlanta.
Atlanta? Never been through it. I've seen them on TV before. All these people walking around. I'm always afraid, what if that thing breaks? Oh my gosh. And I can't swim. Well, I guess the shark came in. I'd be like, I'll punch you in the mouth, brother. Shark ain't no match for me, right, Gracie? I'd grab that thing by the fin, give it a stone cold stunner, and probably swim away with its flap down. Little fin down.
I'm pretty sure the sharks would attack.
You're pretty sure the Sharks do what?
It would not.
You think the Shark would win?
I don't think the shark would attack.
You don't think so?
No.
Well, if it did, I would go like all square root of pain on him. All right.
Grab a piece of shattered glass.
I drop an opposite reciprocal on him. Okay, so what do we see right here? Because I'm just going to make a sketch. When we graph this thing right here, we get a graph that looks like this. We said this point was 8 comma 0 by decimals, right? And we said this point was negative 8 comma 0 by decimals. Kids, what was the distance between those 2 points? 16 feet. Guys, I know I went pretty quickly through notes today, but I got to be honest with you. Oh my Lord. I can't even draw a circle, and I'm telling you, I'm going to beat up Sharks. My little circle kind of reminds me of the Nutter Butter. Questions at all, minions? All right, I think, what time do we end class? Is it 9 o'clock? How about this? Why don't you just start your quick, or no, let's just start your online. How's that sound?